Very good afternoon, sir. Welcome to the event, sir. Uh,
Good afternoon.
Hello, sir. Good afternoon. Good afternoon to all the participants. We are about to start day one, third session. Here we have Dr. Senthilkumar, sir, for handling the session on VR content creation and exploration with the DL. Before starting the session, let me call upon Dr. Udimurthy, HOD in charge IT department, to introduce the chief guest. Over to you, sir.
Thank you, ma'am. Very good afternoon to all. Once again, I welcome Dr.T.Senthilkumar for this, sir, for this wonderful session. So here I am going to introduce about Dr.T.Senthilkumar, sir. So Dr.T.Senthilkumar currently serves as Associate Professor at the Department of Computer Science and Engineering at Amrita School of Engineering, Amrita Viswa Vidyapeetham, Coimbatore. His research interests include video analytics, big data analytics, intrusion detection systems, deep learning, behavioral network security, malware analysis. He completed his BTech Computer Science Engineering from Sage Institute of Technology, Madurai. He then completed his MTech Distributed Computer Systems from Pondicherry Engineering College, Pondicherry. He completed his PhD in Information Communication Engineering from Anna University, Chennai. He has received appreciation in Indian Express for the agent-based programming for banking domain. He has published a book on C++. He is guiding a scholar with Amrita Viswa Vidyapeetham in the area of video analytics, intrusion detection system, behavioral security, and under his guidance, 6 scholars completed research work. He is a reviewer in leading international journals like IEEE, Springer, Elsevier, and more. He has involved himself in developing in the company's areas of programming like MATLAB, NS2, JIST, .NET, Android, Hadoop, Spark, OpenCV with Qt. He is working with Amrita School of Engineering, Amrita Viswa Vidyapeetham, Coimbatore since 2001. He is in charge of the Smart Space Research Lab, which is located in Amrita University, Coimbatore. Thank you.
Thank you so much, sir, for the introduction. Sir, shall we start the session, sir?
Yes, ma'am, we can start now.
Okay, sir. Thank you so much, sir. Over to you.
Okay. Fine, I'll share the screen and I think you can see the screen. Yeah, fine. Hello.
Yes, sir. We could able to see.
Fine. Okay. So thank you to the organizer, and thanks to Udayamurthy sir and the members of SNS institution to have given me the opportunity to talk on an area which is most upcoming. So the morning session, I was able to understand that the guest has spoken to you more about virtual reality aspects and how virtual reality is connected to real-time problems. So I will continue from there and I will try to relate to you about how deep learning can be connected or may be taken as one of the possible approach to solve solutions that you're creating with virtual reality. Okay. Um, See, generally, when you are trying to make any sort of solutions, which could be industry-based or social-based solutions, there are some technological barriers, right? The first technological barrier I would actually say is the camera is a technological barrier because you might try to take some data from one single camera or you might try to take data from multiple cameras. For example, let's take you want to detect me, right, and my face alone, then one camera could be essentially a possible solution. But let's take you just want a system to detect my head movements also on the face. Then that case, one camera can actually detect my face, and the other camera can actually see the movements on the face, right? So that is where you can actually look at multi-camera as a solution, right? So certain problems are basically multi-camera oriented. So there are possible challenges which could include occlusions. Occlusion in the sense one portion of the object being hidden by another portion of the object. And second would be with respect to multi-resolution. The satellite images that you're capturing generally are high resolution. So that's another example. And the need of the day is very simple. Can you have cameras which can calibrate themselves by automatically? The possible example of a calibration which I would say would be is like, let's take you today, you have cameras and you are trying to focus. There is an autofocus option, right? Automatically the camera focuses to closer to the object or far away from the object. So that is an example of a calibration approach that you can give here. That is where you can actually think about cameras as a very eco-friendly uh, support to real-time problems. The next challenge is basically about networking. Though you are capturing data from one place, now the network is the biggest challenge. So can you actually give the data to the end user at a very faster rate, right? Still, there are challenges would be like the network bandwidth is not optimum, but can you develop algorithms which can actually give you optimal transmission? Because most of the virtual reality problems are around the three-dimensional data. So there you need algorithms that need to be created which will have optimal transmission of data. The third is about display, right? So when you talk about virtual reality, people will say that it is not just devices, it's basically head-mounted devices, or otherwise people will say that I have screens which are actually interactive screens. So the cost of an interactive screen, if you ask in 2020 versus 2000, for example, the cost has come down, right? So there's a need for interactive screens to come up. So that's the third challenge in virtual reality problems, which is display. The fourth one is the interaction, right? The interaction is more connected to anything that you communicate with the system. For example, if you have your hand movement going up and down, that's also an example of a interactive system that you can actually develop. Now, the the thought process is like, you want to have systems which can actually interact with yourself. For example, as you can see on the screen, you move your finger automatically, it's understood as a gesture, and the device also works based on the input image that is being captured or the video being captured, and automatically controls the devices. So this is an example of a gesture based control of devices. The next is possibility of a gesture recognition, right? Okay. For example, somebody says, okay, I have my sitting posture. Can I recognize my gesture properly? So that's also an example of a gesture recognition. Next is anything with respect to simulation part, right? For example, somebody stands before a camera and can they actually pick a dress, and that dress can actually virtually come as a dress on the human body. That's again an example of a friendliness which you can provide in VR. The next, what is coming up from the industry side is they are trying to develop devices which are basically touchscreen based, where as you can see here, now this is a virtual touchscreen. So you don't have a physical keyboard with you, you have a virtual touchscreen. So on the touchscreen you type, automatically it is recognizing as the equivalent letters, and that becomes a feed to the system and the system responds. So reality is something different, right? For example, if somebody says, I'm going to a forest, what you saw in the forest is real, right? But here, what you're trying to see is we want to create a virtual reality. Virtual reality in the sense we want to get the environment closer to our human body as like we have been in that particular place. Like for example, somebody says, I went to a forest, I saw two tiger, one zebra in front of me. A virtual reality system would say that I can give you the same sort of environment wherever you are, right? Okay, so you get a virtual environment of the particular place, and you are able to connect to that particular place also in the same environment. And this can actually go to different other applications. For example, somebody is saying that I'm interested in going for some sort of trekking, right? Or I'm interested in looking at my body movement, for example. So there also you can actually look at virtual reality as a solution. This is other one which people are talking about, the distance learning, right? Okay, so people in the most in the abroad are looking at systems that can be developed for the distance learning as part of virtual reality. In this closer to that, you can actually see in the internet, Stanford Clinical Laboratory Department, they have developed a Z space virtual holographic display. Okay, so when you have time, please have a look at the website and get more details. So next is more connected with respect to what you really feel from the virtual reality, right? For example, one of the systems that they have developed is like, can you have multi-sensor systems which can actually have the taste of your tongue and just say whether you have a good taste or you don't have a good taste. Okay, this is other systems which are coming up in the reality side. So you are getting systems which are actually some sort of a jack based systems which you can have it on your body, and whatever you interact with the jack based system, right, as on the body can actually respond to the real time actions. This is something which I'm leaving it as a first part of discussion. This is to get a feel that when somebody talks about virtual reality, it's not just devices, it's more around the data. Okay, it's more around the data that you want to model and it's more around what you want to model with the data. These two are very important, right, when you work on virtual reality systems. Now, with this as basics, we will actually go to the next part. Once again, I'm sharing my screen. Just let me know as you are able to see the screen. So, can you see my screen, please? One of you, can you acknowledge?
No, sir.
No, sir.
Oh, it's fine,
Yeah,
sir.
yes. How it is loading, sir?
Yeah. See, when somebody says, okay, I'm going to interact or I'm going to develop a system as part of my solution, the system as such can be developed with n number of ways. But the question is like, what is the data that you're going to process with the system? The data that you can process with the system can be sensors, or the data that you could process with the system can be in terms of cameras. Right? So I'm coming to the second part where your data that you're going to capture in your virtual realities model is going to be as part of cameras. So if that's the case, then people actually have a fundamental question that what can you do with the camera, right? At best. So I will show you with what we have been doing with our team here. So I give my acknowledgement to the bachelor students in engineering, master students in engineering, then my PhD scholars, and my industry connects who have been trying to strengthen the problem that I'm trying to work on. So here, when somebody says, I want to take deep learning, right, then the next side, somebody would ask, okay, what it has got to do with virtual reality? Today, when you talk about data, and the data is captured as part of a virtual reality system, then the first question somebody would ask is, what is that you should build as part of a virtual reality system in terms of hardware? There, the answer would be is like somebody would say, I need a very good computer, which can actually be a GPU, which can have a graphical processing unit. This is first answer. The second answer somebody would actually come up from the other side is you can actually use some devices like Kinect is a very good example where you can actually have devices for acquiring the data. So Microsoft Kinect is a very good popular device which is used in industry also. So okay, you got the hardware. The third question somebody would ask is, okay, what about the programming side? Okay, when you want to do the programming side, then if you are a conventional coder, you would actually do the coding in Python or you would do the coding in Java, for example. Now the question is, okay, what sort of a library that I should go for working on it? So there are a lot of libraries on the internet which is popularly used. One which everybody would be knowing, right, is most common on the 3D side. Platform, just Unity 3D platform, right? So this is the real-time platform which people generally want to use. So this is one platform where you can actually create virtual reality applications. It could be in 2D or it could be in 3D also. Now comes the question, okay, what do we do with that? So can you do something with that in virtual reality and deep learning? Yes, there are a lot of codes that has come up with respect to Unity platform deep learning, which is based on deep learning aspect, right? So this, I'm just showing it to you because I'm teaching you in which I have learned the same way I'm trying to show it to you. So Unity becomes a platform, right? And you can actually use your codes which you are building on deep learning or machine learning to work with Unity, right? Now, this is first step here. Our second step would be is like, okay, what can you do actually from deep learning side? So deep learning says that I can actually give you any sort of problem to be solved, right, as a set of features. So the features could be smallest feature of an image would be a pixel, right? Or the highest feature of an image would be is like shape is a small highest feature of the image. For example, I saw one paper very interesting where they have built something on recognizing the furnitures as a 3D model using this virtual reality concept. So their shape is a feature. So given some data, what you want to do is you want to first build the features. So the features can be as high level features, which can be like shape, or the low level features, which can be like color, right? Okay. Now, once you've actually generated the features, then you can actually feed it to a model. The model can be a neural network model. And the result of neural network model can actually help you to do something called as classification. So ideally, what you're trying to do is you want to work on problems and you want to recognize whether the data is suitable to the solution or not. So every problem that you work will actually be a classification problem, right? Only thing is the context changes. So here you can actually use deep learning as a solution in virtual reality to solve the problems that you work. So let's see how we can do it. So deep learning is most commonly used because it is more better than machine learning. In the context of only one thing, when you are given more data, the data has got a lot of knowledge, right? So the more the amount of knowledge, the more the amount of accuracy is there in deep learning. So first answer why you want to use deep learning into virtual reality is you can have more amount of accuracy. You can have more amount of accuracy in terms of deep learning. Is my slide visible, please? Hello.
Yes, sir. Visible, sir.
Okay, fine. So the one reason why people want to go for deep learning over machine learning is you want to have higher accuracy. So virtual reality problems will give more of data because you are capturing images frame-wise at every second. For example, you are going to get larger amount of data. So naturally, the accuracy of the model also will be very good. And the second reason why you want to go for deep learning would be is like when the data has got a lot of uncertainty, right? Uncertainty is very simple. For example, if you want to detect a person who is walking, right? Okay, the person walks, suddenly stands, suddenly sits, suddenly stands, right? So there is no specific rule that at this second the person should stand, at this second the person should sit. So there's a lot of uncertainty in the data. There you can go for deep learning. So these two reasons I'm also suggesting why you could go for deep learning for virtual reality. One is larger amount of data, and second thing is the virtual reality also has uncertainty with respect to the data you work. So there are many architectures in deep learning. Usually you should come to a conclusion whether you want to have architectures which actually takes the data and process, or you want to take architectures which can actually remember the past data, right? If you want to take architectures which just takes the data and process, that case you can go for CNN because CNN do not have any capability of remembering part, right? But if you want to have an architecture which can actually take in data and they can process and compare with the previous data, there you can go for RNN, GRU, LSTM, right? And you have a very popular architecture called this GAN, Generative Adversarial Network. So I'll be touching on two architectures as part of VR concepts. One is the CNN and next is second architecture I'll take you through is the GAN architecture. Now, the fundamental thinking why deep learning is taken for most of the problems is needs a very clear understanding with respect to neural networks. See, all of our human body is able to work properly or respond to any actions because neurons are working. Now, how does a neuron work? If you assume it as a perceptron, it means that it has a set of inputs and it is able to give an output. So the inputs are x1, x2, x3. It is able to combine these three inputs saying x1 plus x2 plus x3. If you take these three inputs to be as 0, 1, and 1, the output you'll be getting is 0 plus 1 plus 1, which is exceeding the value of 0. So naturally it will be as 1. Otherwise, the value will become 0 here. This is how a perceptron takes, right? So when you take all these three inputs has got some weights. So you say x1 into W1, x2 into W2, plus x3 into W3, plus you have a bias here. So the bias is a unit bias, which is 1. So you say plus 1 into B is your bias equal. So this is how a perceptron works. But the limitation here is like the perceptron is linear, right? Either it will be either a 0 or 1. So from here, what we look at is like we need an activation function which can give a nonlinear transmission. So need of a nonlinear transmission is the data can actually be falling into any one of the classes. Okay. So that case, now the question would be is you need an activation function. So you can express your activation function as A is equal to F of summation of I equal to 0 to N Wi into Xi. Okay. So activation functions are of two categories. One is linear and next is nonlinear. Example of nonlinear activation function is ReLU when it comes to the deep learning part, right? Now, when you have set of inputs and when you have an equivalent output, now the question here is like how much the weights can be fixed. Normally there is a question here, how do I fix my weights? For example, if there are three inputs, I call the weights as W1, W2, W3. How
மாமி
do I
என்
fix
கிளாஸ்க்கு இப்ப மதியம் 2 பேர் வந்திருக்காங்க. சந்தியாங்கிற ஒரு பொண்ணும் பிரேம்னு ஒரு பையனும் மேம். சந்தியா ஹாஸ்டல் மேம்.
Hello, I think somebody's audio is on.
சரிங்க மேம். நாளைக்கு காலையில் அப்டேட் பண்ணுறதுனா பண்ணிடலாம்.
Dear madam.
Okay. Hello.
Yes,
am I audible,
yes,
sir?
sir? Yes, sir. Yes, sir.
Fine. So if there are three inputs to the data, you call it as W1, W2, W3. Now the question is, how do you fix the values of these three inputs? So there, what we generally do is we use an autoencoder, which can actually fix the inputs on the weights. Now, what are we keeping as learning from here is we need an activation function to work with any deep learning architecture. So the activation function here is F. Okay. Now, this is what a deep learning generally does. A deep learning says I have a lot of hidden layers, so I can learn as much I want. So the number of hidden layers is not fixed in the case of deep learning, whereas in neural network, the number of hidden layers is 1. And next, number of neurons in the case of deep learning is not fixed. Here I can have 6, next I can have 5. But in the case of neural network, I'll have same number of neurons in relationship to the input layer. Next is the weights. Weights are basically going to be available for every data. And next is bias. Now what you see on this side is very interesting. When a deep learning works, it actually goes through the forward propagation and it comes back to the backward propagation. So one forward propagation plus one backward propagation is equal to one epoch, right? But when it is going to the backward propagation, the interesting part in deep learning is it will not take all the weights. Whichever weights has participated in the learning, that weights alone will be taken when it comes to the backward propagation part. This is an interesting reason why people want to go to deep learning, because deep learning can learn which weights have learned for the data and those weights alone will be taken. This is not available in the case of neural network architectures. Now, if this is a question, then what happens exactly with deep learning is a deep learning gives you a set of hyperparameters which are actually set manually by the user. So example of hyperparameters are learning rate, number of epochs, hidden layers, hidden units, and next is activation functions. Okay. Now, a deep learning model will say that I give me set of hyperparameters. I can estimate the parameters for the model. Example of estimation of a parameter is the error. So what is error is the meaning is the difference between the expected and the actual is called as a error here. So you want to have a deep learning model as such wherein the deep learning model has a minimal amount of error. Right? So the error in your deep learning model should be less. So now the question is how long should it run? It can run for 1 time, 2 times, 3 times, 5 times, 10 times. It's up to you. So the more the amount of time you run, the better is accuracy in the model. Okay. Now, you have now understood about what is hyperparameters, what is parameters. Let's take a quick UI part and see how this actually come up on the screen. This is an online URL. I'm not doing anything here. So this playground.tensorflow.org, you can see here, all these are features that you can actually take to a data. Now, the advantage of deep learning is that deep learning can take any type of data. A data which cannot be classified is a very good data which you can take for deep learning. So that is why people say that virtual reality is now applicable for healthcare also, especially for cancer analysis or any sort of malignancy analysis in organs also. They are using virtual reality plus deep learning concept. So any data that cannot be classified, just look at this data here. Nobody can classify it just by any hyperplane. So that sort of data can be given to a deep learning, right? But it needs more time to learn. So in deep learning, as we told you, we can have neurons for every layer. So I can increase my hidden layers, as I told you. At every hidden layer, I can increase my neurons, right? And I can actually calculate every time loss. This loss is what we told you as the difference between the expected and the actual. So the hyperparameters that you can provide will be learning rate. You can set the activation function. You can set what type of regularization you want to have. You can say what type of regularization rate you want to provide here. Right? So once you do it, you are actually running the model. The model will run for epochs. So epoch equal to 1, that means 1 forward, 1 backward. Epoch equal to 2, 1 forward, 1 backward propagation. Right? So this is just a UI just for you to know what actually happens in the case of deep learning. How long should the model run? The model can run for any number of times. That is why people say that you can have more amount of data because the learning will improve when the data is high. It's just a user interaction for us to learn what we quickly saw from the theory part. Right? Now, you will accept with me, okay, hyperparameters are what you provide and parameters are what is estimated. The example of a parameter that is estimated is a loss, right? Now, when you actually look at deep learning as a solution for virtual reality, then there is again one more challenge. The challenge is the model that you create with respect to deep learning should not either fall into an underfitting or a overfitting scenario. What is this underfitting scenario is if you are trying to give any sort of a new data set, right? What happens is the model is not able to work properly because your training data set is very small. The next is with respect to overfitting scenario. What is overfitting scenario here is like wherever you are trying to have any sort of data where the data is provided, but the data has got some sort of a noise, there the model doesn't respond properly, right? So that's called as overfitting here. So any model that you make actually should not fall into an underfitting, nor it should fall into an overfitting scenario. Now, what are the solutions to handle this overfitting? The first solution is something called as cross validation. So what is this cross validation is instead of taking your data as a complete batch, okay, as you can see here, no, you can give a ratio for the batch. So when I say 60%, it means 60% for training and 40% for testing. When I say batch size as 14, that means the entire data is split into batches of 14 size. Same way you can actually do here, you have a property called as batch size, which you can set it in deep learning. The next parameter which you can do with respect to overfitting problem is you can increase the amount of training data. Rather than having 100 records, you can make 1,000, 10,000 records because the learning component will improve. The third is data augmentation. What is this data augmentation is you can actually have the data and you can try to do some operations on the data and make it look different. One common thing which I would say is like if you have an image, you can actually rotate the image every 1 degree. So you can actually rotate in 360 degrees, right? So you'll get 360 images for the same image. This is called as data augmentation. The next is reduction of complexity or data simplification. What you do here is like you actually reduce the number of parameters that you're going to have in the model. The last operation is called as ensembling. What is ensembling is you're trying to combine data from different models. So that's what is called as ensembling about. So principally what we generally suggest is you can take two architectures, combine the architectures and you can use that architecture for handling overfitting. So make sure when you do something with deep learning in virtual reality, it is not resulting in underfitting nor it is resulting in overfitting scenario. Now let's see how your deep learning model will try to learn. Now if it's the model has to learn, then in that case it starts principally with a neural network architecture. This is going to be your data, right? If you take your image that you're going to process here in virtual reality, it is an image, so naturally it's going to be a set of pixel values. So this is your data, right? And this is your expected output. That means this particular row, first row, corresponds to class 1, second row corresponds to class 1, third row corresponds to class 0. Now what we do here is we initialize the weights for the hidden layer, initialize the values for the bias for the hidden layer. Now what we calculate is we calculate the hidden layer input. So that's an equation for it. We multiply the value that you have in the weights in the hidden layer along with the data and add it with the bias. So what you will get is you will get the hidden layer input. Once you've done it, then the next step would be like you want to calculate the hidden layer activations. So hidden layer activations can be calculated by taking whatever values you have in the hidden layer input and apply the sigmoid on it. You'll be able to get the hidden layer activations. Last step would be like you need to calculate this output value. So this can be calculated as two steps. Step one, what you can do is you can take the hidden layer activations, multiply it by what you have in W out, add it with V out. You will get a value which you can call it as output layer input. Then you apply sigmoid on it, you will get the output layer value, which is like this. Now what it concludes here is the model has now learned with the given data. For example, it's an image your virtual reality device has captured. Now the model has learned. Now what the model has learned, It has learned that the first image corresponds to a class with value 0.79, but the class level value is 1. So second, 0.80, third, 0.89. This is your learning score. You can call this a learning score also. Now, you are supposed to find your error, right? So this is similar to the error what you see in the model here. Okay. So now when you look at your error part here, the error part would be calculated as the difference between the output and your value of y. That's a class label. So 1 minus 0.79 would be 0.21, 1 minus 0.80 would be 0.20, 0 minus 0.79 would be minus 0.79. Now it has not become 0, right? Now till now what we have done is actually a forward propagation. Now the next step what we are supposed to do is we are supposed to go through a backward propagation. So we got the value of error. So now the steps that we're going to see is for the backward propagation. Now in backward propagation, we have said that in neural network, all the weights will be taken for the backward propagation. So as a first step, what it will do is it is supposed to calculate the slope at the hidden layer. The slope at the hidden layer, you have the formula here. You can take the hidden layer activations and take the derivative sigmoid on this value. Now, same way, if you take the derivative sigmoid on the output, you will get the slope at the output. Next, what you're supposed to calculate is the change factor. The change factor can be calculated as based on what you have in your slope as the output layer. So you take the slope at the output layer, multiply it with E. E is nothing but 0.21, 0.20 minus 0.7. Right? You will get the value which is your delta output value. Next step, you are supposed to calculate the error at the hidden value. The error at the hidden layer can be calculated based on whatever value you have in the delta output, right? And you take the W out transpose. You can actually do the product of it. You will be able to get the error at the hidden layer. The next step is finding the delta hidden layer value. This can be done by taking the value in the error at the hidden layer and slope at the hidden layer value. You will get the delta hidden layer value. The next step forward is we want to calculate the W out. So this is your equation for calculating your W out. Once you apply it, you will get the new value of W out here, which is highlighted here, 0.29, 0.29, and 0.29. The next step is we want to calculate the new value of the hidden layer. That is also calculated from this equation. Last step, what we will do is we will calculate the bias at the hidden layer. Before that, the learning rate is supposed to be provided by the user, right? Because it's a hyperparameter. So we are providing the learning rate value as 0.1 as initial value. So with this, we calculate what is the bias at the hidden layer, bias at the output layer. Then we calculate the delta at the hidden layer. Now this completes backward propagation. So together one epoch is completed, right? Now if you see the error value is 0.21, 0.20 minus 0.79. Now if you can see the changes, the bias at the hidden value has changed, the bias at the output layer is changed, right? Now again you go for the second epoch. Second epoch means you do one more forward propagation and one more backward propagation. That becomes one more epoch. So what we did is we have run for several thousand times. Then finally, the value that we got with respect to the output was like this, which is 0.98, which is closer to 1, 0.96, which is closer to 1, 0.045, which is closer to 0. Right. So this is what happens in a neural network model. All of you should know this. What actually a neural is. But this is what actually happens in its deep learning also, but slightly in a different way. What a deep learning says is, it says that you have two architectures, either architectures which can remember something, which do not remember something. CNN is a type of architecture which does not remember something. It gives you some data, you can actually have the CNN learn, CNN classify the data to some sort of an accuracy score. Now, when you come to the CNN architecture, you will have an input layer, you will have a convolution layer, you can have a pooling layer, you can have a fully connected layer. All these are called as hidden layers. So let's take you come to some other architecture. They would say that we have something called as block layer, which is also a hidden layer there, right? Now, What can your CNN do with an image that you capture in your virtual reality model? It's like this. A CNN will say that, okay, you give me an image, I will actually apply a filter under the convolution operation. So this is an example of a filter. All of you know what is filters in image processing, right? You know about Gaussian filter, mean filter, median filters. So what will be a convolution layer doing is it's just a dot product part. So it is 1 into 18 plus 0 into 54 plus 1 into 51 plus 0 into 55 plus 1 into 121 plus 0 into 75 plus 1 into 35 plus 0 into 24 plus 1 into 204 will give you a value as 429. Now similarly, you move this filter to the next 3 cross 3, you will get next value which is 505. Right? Similarly, you keep moving, you'll be able to get a new set of values. So convolution as such will reduce the image size. The original size of the image here is 6 cross 6, but what you get here finally is a 4 cross 4. So what is happening here is the weights that we apply with respect to the filter are going to be the very important one in learning. So the weights will learn the data and will extract the essential features, right? And will present the new data just like this. Okay. When you go for deep learning, you can actually increase the number of layers. For example, somebody says, I got 6 cross 6 converted as 4 cross 4, and again want to give it to a convolution layer, you can give it. You can say convolution layer equal to 2. So the output of this will be given to one more convolution layer, and again you can take a new output. So the more the number of convolution layers, the better is the amount of features that you learn from the data. The next is the stride operation. What is stride is like it actually says how much number of pixels you're moving to move on the image, right? So you fix your filter over this image, right? You got a new set of image values. But if you say stride equal to 2, what happens is it just moves 2 pixels right. You can see here. No? First, you're moving the image over here. Next time, you move 2 times right because stride equal to 2, right? So this is what is the advantage of stride. Stride says how many pixels you want to move at a time can be fixed by using a stride. So this is more advantageous when you are going for images which are basically on the remote sensing problems because there the size of the image is very high. So when you have the stride value to be high, you can shift pixels very larger in size and you can get a new image. This is about padding. So what happens in padding is like you are trying to pad the pixels with zeros. So if this is your image, you can pad it with zeros. So what happens here is like the essence of padding will say that the information is not lost, but you are able to work over the image. And padding is also used in one more place, wherever you want to convert data into a square matrix. Originally, it's not a square matrix. I want to convert it into a square matrix. There I can go for padding. So when you do like that, what happens is the original pixels are not getting affected, but still you are able to work with a filter on the given image. The next operation is pooling. So what you do in pooling is like you say that you take every 2 cross 2 and pick the maximum value and keep it. So this is your image. So take the maximum first 2 cross 2. Maximum value is 792. Next 2 cross 2, the maximum value is 856. The next 2 cross 2, the maximum value is 913. Next 2 cross 2, the maximum value is 851. So this is your original data. After pooling, you are converting to like this. So this is like sampling. You are actually downsizing the data, right? And you are able to do it using a pooling operation. Now, if you have an image and you are going through a CNN model, this is supposed to be the output size of the image. So W is the input to image volume, and F is nothing but your size of your filter, and P is nothing but your padding that you apply, and the S as such indicates your strides. Now let's take an image which is of size 32 cross 32 cross 3. This 3 indicates it's an RGB, red, green, and blue. So we apply 10 filters. The size of the filters is 3 cross 3 cross 3 with single stride and no padding. Okay. So now you substitute here W equal to 32, F is equal to 3. Okay. And next P is equal to 0 because you're not doing any padding. And next, yes, you can see here it is 1. Now when you apply here, what will happen is it will be 32, 3, and this will be 0, and this will be 1, plus 1. So totally you'll get this 30. So if you give an input image of 32 cross 32 cross 3, then the output image you'll be getting with respect to CNN will be 30 cross 30 cross 10. Why this 10 is? It is 10 filters. Okay. So this is how CNN architecture works. Now somebody would be curious to ask a question, okay, what are people working on virtual reality and CNN architecture? Yes, people are working on virtual reality models with CNN. I'll show you that. You can see here, there are a lot of architectures. A lot of papers which speaks about how CNNs are used in virtual reality. So this is the first one which I wanted you to know. And in fact, there are a lot of open source codes also, which actually speaks about implementation of virtual reality with CNN together. Yes, this is silly. So here you can actually see codes also being available for virtual reality with CNN. Now, the second architecture that I want people to go through is a very promising architecture that is coming up into most of the virtual reality models, which is GAN. You can see here, GAN. GAN is a very popular architecture. And this is used by most of the companies, including Google, right, and the big other players like Oculus, HTC Live. They are also using this concept of GAN architecture. And in fact, Unity is also working with GAN architecture models. Right. So, small thought process here. So, how do they say here is like this? If you have an image data and you are able to give it to a DreamSpace AI. DreamSpace AI is again a user interactive environment. You have a trained GAN model. Okay, this is what your where your deep learning comes. If you have a trained generative adversarial neural network model, you can actually have an interactive output on the screen. So this one is one of the output that they are showing about the plant growth, right, being simulated over the time by using a virtual reality concept. So the message that we are taking here is, okay, can we go for GAN, okay, generative adversarial network. Now with that, what we'll do is we will go to the concept of GAN architecture. See, the GAN as such was very interesting because GAN says that, okay, you give me data, my data can actually learn based on what you provide, right? One second, I'll share the screen again. Just give me a minute. One second, I'm opening the document again. Give me a minute. Well, if there's any other questions, you can put it in the chat box so that we will try to answer to the questions also. So I'm sharing the screen. Just acknowledge me if you're able to see the screen. Yeah. So, madam, can you see the screen? Hello.
It's loading, sir.
Yes, sir.
It's
Loading,
yeah,
sir, loading.
it's visible, sir.
Okay.
Yes, sir.
Thank you. See, as far as GAN is concerned, GAN stands for Generative Adversarial Network. And this is very promising because this has got a generator and an adversary. It is like, if I say that I am become very intelligent, if you ask some teacher to ask me questions, if I have answer to the questions, then that case I can say that, okay, as a student, I become intelligent. Let's take, I bring one more teacher and the teacher asks me one more question for which I am not answered. Then what I will do is, it means that I am not intelligent. I'll go back and learn and say that, okay, I'll again take a text with the same teacher. So that teacher also I answer, what I feel is, okay, I've learned.
யாரோட மெயில்
So I have learned, right? That means a model is learned intelligently. But after some time, there may be one more teacher who will come and ask me the same question, which is different manner, right? I might not answer that case. I'm not learned. So that's the strength of GAN. GAN says that I will give you a generator and an answer. So both of them will complement each other. But the inner architecture actually uses a neural network. And why are we going for GAN architecture in virtual reality is, you believe that the data that you provide actually has a distribution, right? Even if you give any image, the image will actually have a distribution which you can learn over a period of time. So what is a GAN architecture will say is, it says that you give me an image X, I can predict a label Y. So it means that the probability of estimating it belongs to label Y depends on the input image that you have X, right? So you want to estimate this, and in fact, this is a probabilistic classifier, right, to all your information. But the limitations is very simple, right? No image set is complete. For example, if you give somebody's image and you say that, okay, I've got 360 images of the same person, but it might be possible for the model to take a data of the same person's image with a noise which you would not have thought of, right? So generation of new images as such is not always possible by the humans, but GAN can do that. Because what can GAN do is, GAN will say it will take a data, it will model all possible noise that it can do with the data. Now this is the magic of GAN's architecture, right? This is your ground truth of an image. This is an adversar for it. Adversar, what adversar has done is has created almost a similar image. You can see it, right? But small texture variations will be there. If you ask me where the texture variations are, you can see here, here, you can see here, here, okay, but it will almost be the same, right? That means the adversar has learned whatever is the generator can do. Look at this one here. If I ask somebody which is a computer generated image, this is one of the image which is generated by the GAN, right? Here again, the GAN actually generates almost all possible images similar to the original one. Look at this one here. This is your generated images, right? Now, if the user says that I'm giving you an image like this, the GAN will say I'm going to include some noises on it, and the noise-based images can be like this, right? This also are noise-based images. Okay. So we are trying to see what a GAN can do here with respect to virtual reality. So a GAN as such will have a generator which can actually generate fake samples. And every time it will try to fool the discriminator. The discriminator should not be able to find whether it's a real image or a fake image, right? But the discriminator will always become intelligent over a period of time, because a discriminator will learn or will become intelligent because the generator is intelligent. Like if you say that, okay, as part of your research you are intelligent, I would always say that no, it's not that you are intelligent, your guide is intelligent, right? For example, if I say I'm intelligent as part of my research, I will say it's not that I'm intelligent, my guide was intelligent, my PhD guide was intelligent, right? It's like that. So a discriminator every time will be able to distinguish between the real and fake data, and will become intelligent and better because the generator is becoming intelligent. And both the times or every time, the discriminator and generator will actually train against each other. The generator will have a set of weights, the discriminator will have a set of weights, right? And both the weights can learn over a period of time. Now this is how a GAN's architecture will work, right? So you give any images in GAN, it will take one of the sample of it and it will give it to a discriminator. Now the generator would actually have feature description of the images, and it will apply noise on it, and it will generate a sample. This is called as G of Z. G is your generator, Z is nothing but your latent random variable. So G of Z will be a sampler. Now this is again given to a discriminator. Now the discriminator as such can actually distinguish between the generator and the real sample and say it is which is real, right, and which is generated one. If it distinguishes, then in that case the discriminator is intelligent. The discriminators warn the generator. But if otherwise the discriminator is not able to say which is a real image and which is a generated image, then in that case the discriminator is not won the game. The generators won the game. That means the generator is intelligent compared to the discriminator. So this is actually an iterative process. This keeps going again and again, right? And whenever it wants to improve itself, it can improve two things. One, it can actually improve the discriminator weights if the discriminator has not learned correctly, right? Or it can actually go to the generator and it can improve the weight learning of the generator because the generator has not learned correctly, right? So you can either improve the discriminator or either you can improve the generator. So once you're doing it, over a period of time, what happens is the error which is crucial from the model will actually get reduced. So the error also will propagate to the input in the sense the generator part, and the generator will again have an option to update its weights. This is how a generator works, right? It gives you all possible image for an input image that you capture. How does it generate is based on some distribution. It could be a normal distribution, for example, or you can have your own distributions also for as part of your generator. Now this is a formula for a GAN's architecture. So see the thing, the GAN as such will say that it is going to have a min-max problem. So it every time it will actually formulate itself and saying that it wants to have minimization of generator and maximization of discriminator. That means the discriminator should have a maximization and minimization should be achieved at the generator side. This V as such will actually indicate the notation here, and D again stands for discriminator and G is generator. So V of D comma G, right, will actually be represented as two parts. One where it will try to have a discriminator which is maximizing, and it will have a generator, right, which is going to be minimizing, right. So this, if you can go back and see here, here you can see here d of g of z, and the other one which is from the real part will be d of x. That is why in this equation you have here 1 minus d of g of z, and here you will have d of x. Right? And the equilibrium equation will be indicated based on the data. So as you start generating data, for all possible data, you have a distribution which is p suffix data of x, and you will have a discriminator notation which is d of x, which will be given as 1 by 2 for all the values of x. This is called as your Nash equilibrium here. The next one here is like the algorithm part. You're going to have two parts. One is your discriminator part and next is your generator part. So let's see what your generator does. So your generator as such will actually take the samples, and the samples will be created based on some noise. So you give some input data, it will create m number of samples, which is noise samples. So it is called as Z1 to Zm. And you have a probability function for noise, which is dependent on the generator. So that's called as P suffix G of Z. And every time you will actually update the generator as summation of I is equal to 1 to n. What is m is your number of noise samples, log of 1 minus d of g of z for I. So this I is nothing but 1 to n. So this is what happens in the generator part. Now come to the discriminator part. So what a discriminator will do is a discriminator will say I will run for certain number of steps. So for every step, it will actually first generate batches of noise sample, right? And for each batch of the noise sample, it will actually have a data generation function. The data generation function could be given as p suffix data of x, right? And it will update its discriminator as component of two things. One is d of x, as you saw from the previous equation, and next is 1 minus d of g of, instead of z, we will say z to the power I. Right? So this is what happens in the discriminator part. And here what happens is the vanishing gradient problem. See, in deep learning, this problem will occur in certain architectures. So what is this vanishing gradient is? For certain high value of the classes and certain low value of the classes, the model will not respond, right? Model will not respond in the sense the model will not be able to classify the data at all. So that is where the vanishing gradient comes up. So to solve the vanishing gradient, this GAN architecture, what it suggests is it can try to minimize the value with respect to the generator, right? Okay, it can try to minimize the generated part, the value that you generate. So the function part will be written with respect to generator as a minimization part. So this is some examples with respect to faces. If you have one person's face, the possible faces of the person are expressed as basically the noise values of the face generated by using the generator part. Well, images, as you can see here, and this is the images with respect to room. This is called as a DC GAN. This is again a variant of your GAN architecture. This DC GAN, that's your deep convolution GAN architecture, has a small difference. What it says is it says that it can replace a fully connected hidden layers with convolutions. And it also uses one more concept called as batch normalization after each layer. You can see here batch normalization for each layer being available. Now, this is an interesting part of GAN. If you look at this, people will generally have an assumption that, see, come on, man with glasses, man without glasses, woman without glasses. Right? Okay, fine, it's got detected. Not like that. The understanding is the latent vectors that you represent using your DC GAN is very interesting there. It can correlate the context of the data. See the context. This is man with glasses. Okay, so it recognizes man. Okay, glasses. Man without glasses. And again, you are trying to provide just woman without glasses. Basically, woman without glasses. Now, when you give an image of a woman with glasses, it is able to recognize it's a woman. It's able to recognize they wear glasses from another context. What's other context? A man who has wear glasses. And it labels interestingly as woman with glasses. This is the strength of your DC GAN. So your DC GAN as such can actually capture the context of the data and can relate it to each other very nicely. Man with glasses, man without glasses, together with woman, it is able to capture it and say that, okay, this is a final image of a woman who wears glasses. Right. So this is the inputs with respect to the GAN architecture. There are a lot of variants of GAN architectures like EB GAN is there, Info GAN is there. Okay. With respect to your virtual reality concept, what you have is you have style GAN. Let's see. Style GANs, which is for virtual reality. You can see this is an architecture which is introduced for more of virtual reality concept. Now, what we have seen is right now with respect to deep learning, CNN, and we have now seen very interesting architecture, which is your GAN architecture. Now, let's see the possibility of pushing some code and outputs. Now, if you want to do any code with respect to your environment, you can actually use Python. You can actually use Anaconda. Anaconda is a very popular framework where you can run your code. So if you go to internet and type Anaconda, you will get Anaconda software. Once you install Anaconda, you will get Anaconda in your system. So if you go to your, I have installed Anaconda. So if you go and type Anaconda, you will be getting your Anaconda prompt in your system. Right. So you can see here, you'll get Anaconda prompt. So I have opened it. So this is my Anaconda prompt. Okay, right. Now, the next one that you should know here is like you need Python. Python will come automatically with Anaconda. So you need not install Python. It will be part of your environment. The next one that you need is you need some third-party softwares. So one commonly used software that is used is like you need Keras, then you need TensorFlow, So I'll just go here. You want to install Keras, you can just say pip install Keras. This will connect to the internet and it will install Keras. It's automatic. All you need is a good internet connection. Since I've already installed this, it says requirement is already satisfied. The next one is Keras. So you can actually go here and say pip install Keras. Installed, so TensorFlow. Pip install TensorFlow. Connect to the internet and we'll say it's already installed. So this is what happens. You need Keras, you need TensorFlow, or you will have Keras with Piano also. Right? These are all programming environments for most of the applications, including virtual reality. If you go to internet and type virtual reality code with Keras, you'll be able to get codes that actually is available for working on with TensorFlow and Keras mode. Okay. Now, this is from the most popular website which we are all nowadays using, towards datascience.com, where we have given you some code samples of how to build applications with respect to Keras and TensorFlow as a augmented reality part. Now, the next one would be like once you have installed Keras and TensorFlow, you need to configure both of it because they will not connect together directly. So you need to make this file which is keras.json file. So keras.json file is the next file that you need to make. So the keras.json file would actually be available on the internet. You can download it and you can keep your keras.json file. So I have also kept my keras.json file. I'll show you that. So preferably you can actually keep it where your Keras is installed. So you can see here keras.json file. So if you open this file, you would be able to see a small set of code snippet. This is a standard one, nothing to make any corrections here. But without doing this, you cannot make Keras with TensorFlow or Keras with Piano to work. It's a procedure. So we'll open it in Notepad. Okay. This is your keras.json file. So here you can see here there will be TensorFlow. So if you are going to have Keras with TensorFlow, you can put it as TensorFlow. If you say no, I'm going to use Keras with Piano, you can place Piano here. Right? So make sure that you have installed Keras. You have made a keras.json file like this and put it in the working directory where you are working. So once you're done with it, then the last one that you're supposed to do is, since you're going to work on image processing, in case your application is mostly going to be image processing only in virtual reality, so there you need this OpenCV platform. There you need this OpenCV environment. So you need to install OpenCV. So that will be the next step that you do. So you go here and say pip install OpenCV. Once you do it, it will get connected to the internet and it will install OpenCV for Python. Okay, this is very much important since you want to do image processing of programs. So this completes the platform environment for you to work. And now once you have done it, okay, small workout, somebody says, okay, let me also try some examples. So there I saw this example which people can also work in your systems. So here what they are doing is there's a small user interactive application they have created, which is more or less similar to what you do in virtual reality. So virtual reality says that you are not working with the devices, right? You are not physically doing anything. You are actually moving your fingers, or it's more of a virtual environment. So what they try to show here is like this. So this is your visual desk, so where people can actually move an object and they can just try to type. As they type, it's like, it actually comes up on the text also, right? So it's like a skywriting, for example. So if you look at the libraries, as I told you, they are used in TensorFlow, Keras, NumPy, then OpenCV Python. Then they are used in Google Vision API also. This is also becoming very popular nowadays. Google Vision API. So common command, pip install Google Vision space API. Okay. Then codes are available for it. So I'll show you that also. So this is the code snippet that they have created. Right. And in this, you can see here they have created Python files and they have backed. And this is a Python file, which is a main Python file, which they have created. And all you are supposed to do is you can actually go to your prompt. Okay, so this is you're supposed to go to your prompt. So this is a working folder which is being downloaded. So in this, you can see here there'll be a program called as app. So you're supposed to run Python space app.py. This actually uses one more software called as Flask. Right, Flask everybody would be knowing, right? It's a very popular user interface for Python. So Flask also is installable very direct. That means like you can say
Dear participants, the speaker has some network issue, it seems. So please be on bridge. A speaker will be joining us soon.
Sorry again.
Sir, Senthil sir, have you joined, sir?
Yeah, I've joined them. I've joined them. I'm just sharing the screen.
Sir, your voice is little bit low, sir.
Ma'am, am I audible, ma'am? Hello? Hello?
Sir,
Hello?
it's very low, sir.
One second. Ma'am, is it okay? Hello? Hello?
Yes, sir. Yes, sir. Yes, sir.
Okay, fine, fine, fine.
Now it's fine, sir.
Okay, okay, ma'am, okay. Okay, as I told you, you need a Flask actually to run this program. Once you run it, then you can actually go here and say Python space app.py. Then it will open your browser, right? And you can actually take the URL and post it. So the URL that you need to run here is, this is the URL. This is the URL to run. So you can copy the URL and you can. So this will open you the app. So it's very simple. Like you actually want to write, you can click this and you can write on the screen. Okay, and when you click on this, you can actually write. Again, it will be showing us like it's some sort of augmented reality. It's a very small one, but this is something which you can actually think of at your students level also. Make them to make an app which is like this. They can write on the screen, and this is something where actually it gives a virtual experience and they are not working with the device at all. The next one, which I wanted people to actually have a look at, because people always have a doubt about this virtual reality with respect to vision concept, right? The dimension of the object. And so this is one good app which is on the internet which you can also work with, which is called as ATAL. So this is a user interactive app actually, and here actually you can load objects and you can work with objects also. So if you go here and click start, so it will give you inputs on how to do the code with respect to this, and most of the virtual reality that you want to work, you can work here. And this is an open source one because whatever you code actually you can push it as a script and make them work in the real time. This other one which is airframe.io. The next which I want people to know is like when you work on virtual reality, there are many interesting applications as we saw, right? And, as I told you, even a virtual dress model is also one that is coming up very nicely, right? And nowadays we are looking at apps which are actually which can actually have virtual reality rather than saying just apps. No, people are saying that can it be virtual. So the social media is again taking a very bigger place in terms of virtual reality because a lot of people spend time in the virtual social media. So there you can see virtual reality also taking a very big place, right? And it is also said that when you want to work on medical problems also, people are looking at consultation of saying that okay, can we use virtual reality there? And today with the way where we are traveling, right, in the COVID situation where we want to maintain social distancing, there also virtual reality is also becoming a possible solution to find a contactless COVID solutions being proposed. Right. So the problem that we are currently working on with our team is actually into the fault detection problem. So fault detection means it's very simple taken. Okay, somebody stands suddenly falls. Can you develop a model for it? So that we are trying to take it from a social perspective. So there we are actually taking the data which is coming from the Connect device, trying to develop that as a 3D model. And from there, we are trying to find out whether the person is fallen or not fallen. It's got a lot of possible applications. One is the social space. If you have cameras at your home, your camera at your home can actually say that the person is safe. Right? This is most become important, especially for the elderly people. Some people elderly is there. Are they stable? Suddenly they fall down. Can your cameras pick up, right? So there also you can actually use a virtual reality problem also. as a solution. So that's it from my side. And in this discussion, I think I have given you an insight into saying how you can actually look at virtual reality in terms of deep learning. And I want to discuss this two architectures. One is a CNN and GAN architectures, because both of them are complementing each other in the learning part itself. And applications is left to you. You can take any application. Only thing is you should have some good knowledge in Python. Preferably you can take Unity. It's a very good platform, which is open platform where you can push the code. And now for deep learning with Unity, there are a lot of third-party kits that has come. So you can actually take the third-party libraries and use it from hello, hello, am I audible?
Sir, no, sir, little bit louder.
Okay, am I audible, ma'am? Hello.
Yes, sir.
Okay, fine. So this is what I wanted to deliver to the audience. So when you want to take your problem and work with virtual reality, just see whether you want to work in a 3D or a 2D space. That's a first checkpoint. You can actually work with 2D also in virtual reality. Or if you want, you build a model from 2D to 3D also is a good solution. But second thing is like the programming platform is also very important, whether you want to take it free, you want to work with any specific hardware, because most of the hardware prototype, they actually use
Sir? Ma'am? Dear participants, the speaker has some network issue and he couldn't able to continue with us. Sorry for the inconvenience. So we wind up this today's session by saying thanks to the speaker. The session was very much wonderful. Speaker is about to join now. Let's wait for one more minute. Sir, I hope you have a network issue, sir. Shall we wind up the session, sir?
Yeah, ma'am.
Thank you so much, sir, for the wonderful session you gave us today. We have to thank you for taking our invitation to handle the session. And
I think Sir is speaking something. You please
okay, ma'am.
check with Senthil sir.
Yeah, I'm talking, ma'am. I'm talking.
Sir,
Sir,
Thank you so
because
much.
it's very low.
Madam, am I audible? Hello, ma'am?
Now you are audible, sir. Now you are audible.
Yeah, fine. Yeah, thank you so much. And thanks to Dr. Nitya, ma'am, Vidyapeetham sir, and members of SNS institution. And I keep my credits to my and pranams to my guide, PhD guide, Dr. Shivanandam sir, because he's the person who is elevated to what I'm working on deep learning for this. Right, and thank you so much, and thank you all for the opportunity. I've dropped my email ID. If there's something of common interest you want to work, please drop me a mail. Thank you, ma'am. Thank you.
Thank you, sir. That was a wonderful session. Thanks for accepting our invitation to take part in this event, sir, to share your knowledge in this session. The session you handled was very much nice, interesting, and it was an eye-opening session, sir. The contents you shared on deep learning and the models used in deep learning and how we can connect with VR to deep learning, that was very much informative. And earlier we were thought of VR and AR to be in 3 dimension, but you have given us an information like 2D and 3D can also be included in VR. The session provides insight to connect deep learning and virtual reality a lot, sir. I hope the participants have gained much knowledge out of the session, and it also will help the young researchers in this deep learning and VR domain to take part to the next take the things to the next level. Thank you so much thanks for the session.
Thank you, ma'am. Thank you all.
Thank you so much, sir.
Thank you.
Participants, we are winding the session today. We'll be joining for the next session tomorrow at 10 a.m. Kindly join the session 5 minutes prior to the session. Thank you all so much. Have a nice day. Thank you.
Thank you, madam.
Thank you, ma'am.